Hey everyone, welcome to the April Town Hall. Really glad to have you all here. So, as usual, before jumping to the main agendas, I'm going to hand it over straight over to Alisa to kick us off with some community updates.
Thanks, Lakshay. Hi, everyone. I'm Melissa, and I'm the community manager here at DataHub. I want to begin today's town hall by providing some updates on the community side. So, on April 10th, we hosted an in-person hackathon in San Francisco with Nebius and Entrepreneurs First. We had three winning teams. The first place went to a project called DataHub Agent On Call. So, the winner built a 4-agent incident loop that automates on-call triage. Second place was Project North Star, an anomaly to resolution copilot. And the third place was Medigard, which tackles healthcare data quality guardrails. We were deeply inspired by the energy and the quality of the submissions, so we're actually now planning a very large-scale online hackathon in the second half of 2026 that removes the location barrier and opens submissions to community members everywhere. So please stay tuned for the updates. Next page, please. So yeah, looking ahead, we have some exciting lineups on our community events calendar. First, Swaroop is actually doing a fireside chat with the Stanford Business School Tech Club on April 28th, which is next Tuesday. He's talking about how metadata becomes the foundation for trustworthy AI, the open source playbook behind DataHub's community, and also scaling lessons. So registration link is on this slide, and we'll also drop it into Slack as well. So we hope to see you there if you're in town in the Bay Area. Secondly, we have community meetups coming up in Toronto in May, Chicago in July, and also in New York, hosted by our customers. Details will be shared as they become finalized. And then moving on to the next page. We're very excited to welcome our founding cohort of champions to the DataHub Champions Program. They will be actively helping out in our community, responding to questions, hosting events, and shaping our product roadmap. We expect them to take very active roles in the community, so please be on the lookout for our champions in Slack and also in other type of community events. And in fact, one of our champions, Stars, he will speak at today's town hall, so we'll hear from him directly today. Moving on to the next slide, we actually have an ask for you and a public service announcement. We crossed 15,000 members in the community as of 2 weeks ago, which is a really big milestone for us. We put together a very short survey to hear directly from all of you what's working, what's not working, and what you want to see more of. So the link is on the slide, and we'll drop it into the town hall Slack as well. Every participant who completes the survey gets a $25 Amazon gift card. And we'll share key takeaways from the survey results in the May town hall. So your input really directly shapes where we invest in the community next, and we really appreciate your time. And without further ado, I'll hand it over to Lakshay to cover today's agenda.
So, thanks, Lisa. Really excited to see the champion program come together. It's a great group of people using the ecosystem forward. So, yeah, all right, let's get into what we have got lined up today. First up, Pinterest deep dive. Gu Zhang Li and Martin Yao and Aman Gairola are going to walk us through how they built a unified context layer on DataHub to power their analytics agent and text-to-SQL in production. Real engineering deep dive, really solid session. So stay tuned. After that, Peter Whitehead from Omni join us for a live demo of their new data integration. And big congrats to the Omni team. They just announced their Series C today at 1.5 billion valuation. Excited time, Peters. So then we have one more thing from the DataHub team, a new open source release that I'm personally really excited about. I will leave that as a surprise for now. And we will close this with a community spotlight from Josh, one of our community champion from PassionBytes. He will share his journey from using DataHub as a catalog to building AI workflows on top of it and contributing back to the project. All right, Pinterest team, the stage is yours.
Hello, can you guys hear me?
Yes, Aman. Yeah, but
All right, awesome. Um, Thanks everyone. So we are the Pinterest team. We are here to share how Pinterest uses DataHub as the backbone for data governance and how it forms the foundation for our AI-powered analytics efforts. I'm joined today by Kachang, who's built the analytics agent and the AI context layer for us, and Martin, who works on the DataHub feature support for the Pinterest context layer. So this has been a multi-year journey, and we're excited to share with you what we've learned, and I'll walk you through what we're going to talk about. So here's how we structured the talk today. So first, I'll walk you through the governance challenges that we faced. Our data lake was unsustainable. We'll talk about how we built our operating model, why the policy setting that we did alone was not enough. And then Martin will show you how DataHub makes those policies real in the platform. Then Kachang and I will walk you through how we extract, represent, and scale institutional knowledge using AI from automation for generating documentation to context curation and eventually to the production analytics agent. So let's start where we were, right, a few years ago. Pinterest Data Lake had over 400,000 tables. There was no lifecycle policy, retention, or cleanup. Tables were created freely, live forever. You got 500 new tables showing up every day with no governance. The top 500 most queried tables, still around 80% of our volumes, were more than half, right? And there's no documentation around it. And roughly a third of it was owned by people who'd already left the company. So analysts were sort of spending a lot of their time reverse engineering trust, going through code, tracing lineage, dropping Slack messages, etc., right? Hoping and praying that somebody responds. Um, Knowledge existed about what was happening. However, it was extremely tribal, fragmented, right? So how did we fix this? Step one for us was to establish governance policy. That alone, though, wasn't enough, right? We started by writing governance standards, but a policy doc isn't going to change behavior, especially at the scale where you have like 500 new tables showing up every day. So we needed to operationalize governance from in the platform itself. And that's where sort of Data Hub came into the picture. It became the system that made governance accessible and actionable. Every table creation got gated through the Data Hub UI. And so if you do not provide tier owner retention domain, you don't get a table. Hive Metastore prevent listeners also enforce these requirements at the Metastore level, so metadata can't be bypassed. So we took a phased approach to start adoption, started with 5 tables, then 10, and eventually scaled across the entire company. So then what does this governance operating model look like? There are 3 pillars here. At this point, I think, Martin, I'd like to hand over to you to talk about our Data Hub efforts.
Thanks, Ivan. So first concept is tiering. So basically not all tables really need the same investment. Our tier 1 tables are the highest quality tables that are used across team, and they come with very strict documentation and quality requirements. While our tier 2 tables, basically they need less requirements, such as just the owner, description, domain tag, but they still have a good amount of context associated with them. Our tier 3 tables, on the other hand, are basically all the new tables, and initially they always don't really require any governance requirements, but they do have aggressive retention. So they will get automatically deleted if they don't get promoted and have context associated with them. The second concept is ownership. So we always, for our tier 2 and up tables, require a project identifier. So basically that is a team of Pinterest, a group of people, as opposed to a single person. So that way we can retain the accountability. So no table is only associated to one person. We also require a domain tag, so that's more at the org level in terms of associated ownership there. Third concept would be our lifecycle policy. So we always enforce retention at the creation time of a table and have that tier-based cleanup implemented where these tier 3 tables get automatically deleted after a very short period of time. All of these policies has brought us down from like almost 500,000 tables to just about 100,000 curated AI-ready assets in DataHub. The tiering helped us create focus on what we wanted to use for context, as we couldn't govern everything equally, but we chose to invest deeply in the tables that drove the majority of the queries. The next slide. We require every table basically to declare its owner, the retention and domain very shortly after the creation time. The governance gate ensures that no ungoverned table enters the warehouse and stays there. If the metadata is not provided, tables don't get to stick around. We initially rolled this out in phases where it's first optional and then gradually started to enforce this retention policy. And nowadays, we have mandatory creation flows for all the new tables. As a result, every table that enters the warehouse basically and stays there is governed and AI ready from the start. So that's essentially the governance model. But what does this look like inside DataHub? So this is our DataHub deployment. We call Pinecone in Pinterest. And this is an example of a governed table. On the right-hand side, you can see the summary with the documentation, the owners, the tags as well. In the main view, every column has a description and also a type, glossary terms. The glossary terms help us enable cross-team interoperability as different tables with the same glossary terms can be safely joined. All the governance constructs we just described, basically shown right here, enforced right here in DataHub. And our metastore restrictions help us ensure that none of this metadata is changeable outside the platform. All the knowledge, institutional knowledge, is centralized in one place in DataHub, and DataHub serves as the source of truth for this data. So yeah, all this governed structured metadata is what makes everything we'll show you next possible. Beyond just dataset governance, we also extended it to our workflows. So we use a fork of Airflow. Beforehand, we relied on sort of a code-based configuration where users set their tier, their SLOs, the ownership. But this resulted in people just arbitrarily setting tiers and sometimes assigning owners that were just simply not valid. Nowadays, we have it all in DataHub as well. And the tiering promotion process or demotion process is also implemented using DataHub. It's a similar concept to datasets where all new workflows start at tier 3. And tier 3 workflows can get deactivated if they fail continuously. All of this effort is mainly to reduce the cost of compute, while the dataset governance was mainly to help reduce the cost of the storage costs. Additionally, for our automated demotion process, we have workflows that get demoted based on SLO and continuous failures, different criteria, and eventually they may get deactivated as well to stop incurring cost. We have a similar promotion process as well. So workflows that go from tier 2 to tier 1 must be reviewed by spend captains and our compute team based on cost. Similarly, our data sets, we required data stewards to review those tables. So all of it's quite similar to dataset governance. All of this ensures that only the workflows that matter and have proper justification get to be tier 1 and run with our highest priority. But in the future, we also plan to further enhance the workflow metadata in general with more SLAs, more metadata to further improve context for our agentic purposes. Now, beyond just governance, DataHub here at Pinterest really serves as a fully centralized and self-service portal for everything from discovery, analysis, charging. It really helps eliminate all the knowledge silos. So as you see from left to right, we have the data generation, all the workflows, the tasks, all of that's mapped properly to the data sets like the Snowflake, Iceberg, Hive data sets that we have in our DataHub deployments. And from those data sets, there's also the mapping, the lineage to the actual use case of that data, the visualizations, how we use it for the metrics, for example, our superset charts and dashboards. And in the future, we'll work on ingesting all the documentation. Our documentation is currently still fragmented, Google Docs, Confluence, PDocs. But in the future, we plan to get all that documentation inside to really curate and have as much context as possible that can really help improve our agentic purposes, leveraging DataHub as that one centralized place. That's how we've used DataHub for governance, and Amon will walk you through some of the challenges we've encountered with the context and agents.
Thanks, Martin. So one of the big challenges we have is dealing with schema complexity. Essentially, what happens is over the years, we've kind of built mechanisms for ingestion that bring in data into the data lake. In these scenarios, over time, the way the mechanism has evolved is we've used thrift-based nested data structures for data ingress, resulting in a very flexible logging. Anytime you log something, you already have the structure in place, no schema change needed. However, those who are analyzing the data bear all the complexity of transformation to figure out what data should look like. Over past many years, this has grown organically to the point where we are completely dependent on tribal knowledge to understand the representation of the data and also in production scenarios to debug any of these situations, right? So we always have to have experts who are on standby, without which we cannot operate. What this created was a need for a sort of accurate representation and discoverability of our metadata in order to break the knowledge silos. So here's an example, right? What we call the feed view log is a basic ingested log, which is basically a representation of the feeds that people see on the Pinterest app. It starts with a feed view, which represents a unique user feed. Inside this, you have the nested object view, which is basically a representation of the contents that are shown to the user in the feed, within which is nested the user action, which is then stuff like clicks, impressions, and these are multiple. So you get this deeply nested structure on ingest, which is kind of very difficult, right, for an individual to keep track of, especially as it continuously grows. In order to track all of this metadata, we've started putting in enums and other definitions into PinCat so that as we create entities that define each of these sort of business side entities that we utilize, we're able to start preserving some of this context for reference by humans, first of all, so that anybody who's on call on the team can actually look at detailed metadata, both of like what the enum definitions are, what the individual attributes are, some of the key embeddings within it, right, become the SQL fragments, right? How do you discover something? How do you find what does something mean? So all of this is sort of captured here so that our on-call can reference this and take action as needed. And domain experts can then add more context to make it more searchable. Second follow-on impact it has is that it enables us agent-assisted workflows, because essentially now agents can use this metadata to generate more efficient queries on the complex ingested data. So over time, as humans are less able to read and understand the complexity of the data representation, you're going to have agents that are able to interpret this more effectively, right? So in our situation, what we did is we built the analytics agent and we tested it with general context. And what we found when actually we added the feedview log context to it, that it turned from the analytics agent to the analytics sage, where essentially it could go from a very directed series of prompts to get to an answer to something which could debug a production problem when you gave it like text about here's what I'm seeing, and it can go from the symptoms that you're observing to the root cause in like a single step or two steps. We used Claude 4.6 Opus for both agents and ran both sort of in balanced mode. And what we found was the analytics agent without the domain context was running long-running queries, multiple prompts, more resources, and also needed the user to introduce custom filters to get to the right answer. So the addition of context really accelerated our problem solving. That comes with other challenges. One of the problems that we saw is basically the fragmentation of context. As more and more teams build their own agents, it results in duplication and consistency challenges. I'll give you an example, right? So finance built their own agent, started building a corpus of their own context, as did marketing, as did safety, monetization, and analytics. Now, what starts happening in this scenario is that you get certain universal shared context, which is consistently understood and implemented across the company. This, as you probably can envision, is a very small subset of the context corpus. The majority of the context is going to be sort of domain specific, where it may be either shared across domains or it may be only relevant to a specific domain. What that means is that while there is sharing of context across domains, and also domains are being shared across agents, there may be areas of overlaps. And these overlaps may not also necessarily be areas of agreement. You may have divergent definitions. And while some of this seems to converge organically, a lot of it is just divergent. So what do we do in this situation, right? So I'll give you an example of how we curate context. So for example, imagine a world where you've got the analytics agent, the monetization agent, finance and marketing, and everybody has their own agents. There are certain definitions that exist in this space. So for example, DAU is a combination of daily active users, removing bots from it by safety. You end up with marketing's view of daily active users. Now, for example, somebody from finance wants to curate daily active user definition, which is finance specific. They're going to add that content within the finance domain in the context layer. However, what's going to happen in this scenario is that you're going to potentially have either conflicting definitions or overlapping definitions. And what this means is while context addition by individual teams will help multiple agents because of the context layer and prevent duplication, it can also lead to conflicting definitions. So our proposal is we build agent evaluation mechanisms in order to make this process a little bit better. So currently curation is highly dependent on the efficient accuracy evaluation mechanisms, right? So we're representing them as key questions for each of the agents that they must answer accurately. Uh, let's just call it accurately in order to be considered healthy or reliable, because the definition of accuracy is something that is still being incrementally evolved. A subpart of the problem is basically consistency between the domains, right? So we have DAU definitions which may or may not agree with each other, right? And at the same time, they may be divergent, but the agents that reference them must have at least some consistency of answers when you add context. So for example, in this scenario where you've added DAU for finance, you have both these definitions and both of these agents. Once you validate your context locally, you have to validate it globally through a regression test as well. So that what you must understand here is that the finance bot must perform and respond to questions accurately, same as the marketing agent, right? And only once these two agents are sort of certified can you roll something out. But at the same time, one other evaluation that needs to be done is that you have to make sure that shared context is not just you're performing regressions for it, but you're also performing validations across domains. And these are sort of, once the evaluation scores, you find them to be suitable, then the context change gets rolled out to production to make the process a little bit safer. One thing that we've developed is basically local evaluation, which gives you the ability to iterate quickly over context by domain experts across the company. The idea is that you've got your own dev box, and before you have to actually, do a Git push to get any of this into the repository, you can evaluate it against sets of questions on your local environment in order to ascertain how accurate it is and whether it is an improvement over the production metrics or not. A second on commit workflow helps integrate the same evaluation mechanism across multiple agents as well, so that this way you can on commit verify if all the other agents are behaving correctly, especially if you modify certain global context which everybody shares. And in addition to this, you can sort of also share the results so that anybody who's verifying that this diff can land in prod has all the stats available at hand. So now we've shown you the schema side of the institutional knowledge. We're talking about, tables, columns, etc., right, and the documentation. So all of these metadata entries and entities are governed and centralized in DataHub. And we're going to basically now be talking about a second dimension of knowledge, right, that you already have, but it's been sitting there underutilized. And this is basically the analytics space. So which describes the business logic, the intent behind the analytics, right? And so if you look at the analytical SQL queries, that's what it represents. So up next, Khachang is going to share how we are building and enriching both these dimensions by using AI to scale documentation from the schema side and encoding the query history as institutional knowledge on the analytics side. The result is going to be a rich context and semantic layer that connects user questions to the right data entities and metadata. Over to you, Khachang.
All right. Thanks, Arman. So my name is Ke Jiang, and I work at Pinterest on the building and designing the data analytics agent. So for the sake of time, I might be going through some of the slides a little bit quicker. So with the data governance effort, Arman just talked about, we now have the very well governed data entities and metadata in DataHub, but you remember that we have 100K tables still, and most of them are missing proper documentation. And manual documentation for 100K tables is just not feasible. And uh, and we know that schema level documentation is actually the foundation both for human consumers, but also for the agentic products and features we're building. And how can we actually scale documentation to 100K tables? So we tackled it on 3 fronts. So the first one is we actually use LLMs to draft table and column descriptions from existing code, glossary terms, and representative queries. And we surveyed our users, and the response was actually pretty positive. For 75% of the documentation we generated, the user responded with it's at least usable or better than that. And we used human review in tier 1 tables, which in Pinterest is a very small set of tables, like a few hundred tables. So we still have that last human review for the most important tables. And second, we used join-based lineage to propagate the glossary terms through join queries. If a column is joined with a column that already has documentation, we can propagate that column documentation over to the other. And the third one is the join is very, very sparse. So we can only cover some of the columns. But for the remaining ones, we used actually the vector similarity search to compare to relevant columns for existing columns to propagate that documentation. Overall, that saved us all these 3 efforts saved us about 70% of the manual work. Next slides. And for all this documentation we created, for all this metadata governance we implement in DataHub, what can we do about it, right? So humans are the first to be benefited from. They use those to write queries to try to find the right table and then write this right SQL to get the data they need. But we wanted to make the experience even better for our analytical users. That is to build them a production analytics agent that responds to analytical question with a trustworthy answer. So, for example, such as this question here, which campaigns had the highest ROAS last month? The question itself is very, very simple, but if you will think about it, how can you actually solve this question? How many, aspects are we looking at? What are the factors that play into solving this question? Remember, we still have 100K tables. I actually added 98K superset charts into this because sometimes we want to lead the users directly to those charts. And you might ask, can we just build it with a simple RAG on top of the documentation and schema we built? And that will solve all the workflows, user workflows, including question answering, text-to-SQL, or synthesizing a complex analysis report. Would it just work? The answer is yeah, sometimes, but no for most use cases. Why? Let's think about what's actually important for the agentic workflows. That is to provide relevant, but also business specific and high quality answers from a huge inventory of data entities that vary in relevance and quality. Next slide. Let's first talk about like how RAG actually works and how it would break if we just build it on top of the enriched raw schema metadata or documentation we created. So I had 4 examples. I probably don't have time to go through all of them, but if you look at some of the examples here is the descriptions of the user question doesn't always match to the table description, right? And a very relevant table actually probably is a staging table or a deprecated table that doesn't provide quality. And only when certain tables are joined together that can answer a user question. And also we have company specific things that are embedded in either documentation or in existing query, then no one knows how to find that query, right? These are specific logic or intent that we find that's very, very available in user analytical queries, actually. So I just showed you that throwing everything into a simple RAG without any further indexing, enrichment, quality-based ranking will break. But what actually works? So don't get me wrong, RAG still works. The gap is what your RAG is built on and what it actually can retrieve. Next, I'll walk you through our approach. Next slides, please. So our approach focuses on two principles. One, we build a context intent embedding. The name is very complex, but underlying the principles is very simple, is we do not just embed or build the semantic on the raw artifact. For example, the SQL query itself. We actually injected governed context from DataHub, such as glossary terms, table descriptions, and domain assignments before creating the semantic embedding. And the second thing, we call it governance-aware ranking. This happens both in the SQL parsing phase, but also after we, when we're serving the user request. We combine the semantic similarity weight with governance signals from DataHub. Those include tiering and freshness and documentation grade, and also sometimes usage frequency. So we already covered both of this in our blog. I will show you the link to the blog post, but I'll walk you a little bit more in detail with both of the choices we made. Next slides, please. So what we call this, your analyst already wrote the perfect prompt, because every SQL query that your organization ever written captures real domain expertise. The tables the analysts chose, the joins they built, and the metrics they computed. We treat this history of queries as a library of real solutions written by real analysts. So if you look at the top blue path, the parsing has 3 steps. Step 1, as I talk about, is the context injection from DataHub. And step 2 is SQL to text. We actually translate all this context together into possible questions the user is trying to answer using that SQL, and high-level summaries of the SQL. And then the last step in the first path is text to embedding. That's where the semantic or intent of that SQL is represented. And the underline, the orange path is, the yellow path is more about the structural and relational patterns we extract as structured data to serve the retrieval path. So the two combined together actually works really, really well. And next slide, please. I had this slides to show a little bit more detail of how we build this, but the focus here is the green part, is like we actually translated this SQL to get some to actually get the SQL summary and purpose, and also most importantly here is the analytical questions. So here I'm only showing like one, but from one SQL we actually parse out 3 to 5 possible questions that SQL can possibly answer, and that really maps very, very well when during the analytics agent to serve a user analytical question. That it creates a lot of non-existent connections before this enrichment. Next slide, please. So we actually think those two principles apply across all the data entities, not just SQL. Now, let me show you a little bit about how it applies to things like superset charts. Next slide, please. So we also have, as I shown you earlier, is a large inventory of superset charts. And for the Analyst Agent V2, that's a new type of assets where inventory into the Analyst Agent. But we still have the similar problem, is how can you semantically express each chart in the agent context? And we do believe if we apply the same principle, it will work. If you look at each dashboard or each chart, they already have the structured metadata, and we can still do the similar enrichment when as we did for the queries, to extract user intent based on maybe the SQL query that queries the data set backing the charts or how people are actually interacting with those charts and dashboards. And we can also ask for documentation from the owners of those boards and charts. And we also are working on the governance policy on top of it to really implement the principle too. And I'll skip through this because it's the same thing. We can do this for many entities using one mechanism. And then the routing layer is what's really important is now we have curated tier 1 dashboards or charts. We can actually route our users to that layer first because that's the most trustworthy data. And we want to show the results directly. And if a certified dashboard answers the question, we should surface it without generating SQL. And then we redirect users to high tier tables if that path is not existing. And then low tier dashboards would never override high tier dashboards. The agent is tested for this. Trusted governance signals over recency and semantic similarity. Next slides. So we actually, you might ask, why do we build all these complex index over all these data entities and why the ranking is important at all? So it's actually because we surveyed our analyst population on the V1 version of the agent, and 30% of them are asking better data discovery. And in order to do that, we need to build better semantic and intent layer to map the user question into actual data entities. Next slides. So I want to show you the agent in a very high level. So it runs on top of those two principles we built. It runs on the index we built for all the data entities. So every time an analyst writes a query, and then we create an index on top of that, which benefits the next analyst to enable them to run a variant of that query. And then in turn, that will benefit future use cases as well. Next slides. So the last thing I want to share is our stance on DataHub and what your takeaways can be. So as I showed you, we really are right now focusing on the data discovery front. And the most important thing we realize is good governance before AI is beneficial in the quality of the responsive agent, but also that helps with the ranking, help with actually to understand the user intent if you could have good governance signals as well. And we're using DataHub now as the centralized context place for all AI agents. And we built this one index, not many. Here, it's not like the entity types. It's the certain type, it's the intent index we're building centralizing in DataHub. And we are indexing behavior, not the schema. I think that's one other takeaway is schema itself is very helpful, but how are people actually interacting and using that is even more important when you want to map user intent into actual queries or solutions. Yeah, I think there's a quote here is the most effective system carry forward what an organization has already learned. So that's your query history, your superset charts, and whatever your organization has. And the last piece is I want to share our blog. It has a lot of more details than what I just talked about. And feel free to take a look. And thanks all for participating.
Awesome. I think I'm up next. Hello, everyone. My name is Peter Whitehead. I'm the Partner Solutions Engineer at Omni. And today I'm going to introduce you to Omni, as well as our brand new DataHub integration, and then also talk briefly on where's Omni's semantic layer fits into the overall governance layer and how we think about allowing data teams and business users I like adding context back into the semantic layer to get the most out of those AI insights into their data. So let me share my screen. Oh, wrong button. So what is Omni? We are an AI analytics and business intelligence platform, and I'm excited to announce today we also did just announce our Series C round of funding, so it's a big day for us. Omni is built directly on top of a semantic layer. Now, the semantic layer is all of your company's business logic, but it's also a context layer where your data team can provide context not only at an overall schema level, but all the way down to a column level as well. So end users can actually get trusted insights into their data. Now, Omni allows for users to interact with data in many different modalities. It could be typically through conversational analytics, through natural language, but we've seen that as just the entry point into data. Then users can take over the wheel and start having different interactions with the data. If it is a traditional sense through, or a traditional BI sense like point and click UI or dashboards. Also, we allow users to interact with spreadsheets directly in our business intelligence platform with, a one-to-one syntax match with Excel. But also users can write raw SQL, or we even created Omni to be extensible and allow users to interact with Omni directly in their own with Omni's MCP in their own AI agent of choice, or via the Omni CLI or API. So Omni's semantic layer is, perfect match for the DataHub governance layer. And that's really why we wanted to build this integration. So what this integration is, it is a pull-based methodology from DataHub through the Omni API to pull in all of those objects from the business intelligence platform of Omni so that you can see how it fits within your data stack. It's going to map different objects within Omni, which I'll get into in a second. But essentially, it is just where that content lives, the actual content, and then our semantic model, which is made up of semantic objects like topics, view files, dimensions, measures, and it's really going to give your end users end-to-end visibility across their entire data stack and where Omni fits in there. So it goes from raw database tables to that transformation layer. If you're using something like dbt, Omni does have a two-way dbt integration, so we can see how that maps to the underlying views within Omni, and then all the way up into the semantic model in the dashboards, workbooks, or AI workflows on top of that. Now, how Omni's structure is structured is here's like a object hierarchy, so you can kind of understand our layered approach to analytics. Up top is going to be the consumption layer. That's going to be the dashboard or workbook or AI workflow that you're working in. And each dashboard is going to be comprised of separate workbook tabs. Each of those tabs is going to be an individual SQL query. And then below that is our model. Now, we think of Omni as a layered model approach. We don't want to have just one standardized model because we know there is different interactions of data that you need to do, and you need to sometimes break out of that semantic layer. So we have a shared model with a true get back workflow into it. And that is the standardized business logic in context across the entire organization. Think back to the Pinterest slide where they had the Venn diagram. Think about that circle, that center. That is exactly what that shared model is. Everyone has that same shared context. But within each workbook, users might need a specific, exploratory metric, or they might need to define something slightly different in sales versus finance. We give them the tool sets to make those changes in the UI or through our YAML file so that they can have that directly in their workbook and in their dashboard. Now, to take a look at this at a dashboard level, each dashboard is going to have their own individual dashboard tile. They are visualizations. Those are going to be mapped to either one or more workbook tabs. And then you can get that column level lineage all the way down into the dimensions and measures that make up those tiles. This could be any type of visualization. It can be an AI summary tile, all of that good stuff. Now, from the model's perspective, this gives a little bit more breakdown over what the model actually looks like from the layered approach. As you can see, each the workbook model and the shared model are going to be essentially the same, but different with the metric definition slightly. It's going to be comprised of view files, which are going to be representative of a table on the underlying data warehouse or one that's derived like a SQL query. Our relationships file is codified join relationships, so we don't need to redefine those every time we want to use them. We can just call back to a specific definition. And then a topic. Think of it almost as a virtual data mart or a curated data set for a specific type of analysis. We define which joins live within that topic and the context of that topic. So, for example, I'll demo a little bit later, say an opportunities topic for Salesforce data. We define a ton of context into that topic. So it is a common set of data questions, maybe sample queries, things like that. So users who might be speaking in different nuances of their language are all getting the same insights out of it. And then below all of those layered approaches is the schema model, which is the metadata from the information schema, and then finally the data warehouse schema. So really the context layer and semantic layer, how we think about governance at Omni is exactly why we wanted to build this integration with DataHub, because we thought it paired so well with their governance layer. And we also, to push us along even further, is we had many customers and prospects asking for this integration. So we wanted to make this something for all of our new customers coming in. So how we built it, I am not a software engineer. I am a solutions engineer. So I work with all of our technology vendors, our consulting partners. And so I built this with me and my friend Claude. When I first started my foray into this, it took a lot of back and forth with Claude, and I was struggling a little bit. And it was really, if you think back to that layered approach, I was struggling unraveling that layered approach, and I was getting a lot of circular references within DataHub as I was first building this and testing this on my local host. But luckily, the DataHub team came to my rescue, and they released their new DataHub skills. And I was able to leverage those to really accelerate my timeline and actually get this out and be able to commit this to the project. So what I did was provided those hierarchy diagrams I just showed as context, as well as our API documentation, our CLI documentation, and some other internal documents, along with the integration planning skill. And I was able to have a quick back and forth, and I was able to get an MVP out the gate in like one day rather than the week before when I was trying to build this. And then it gave me confidence to use the PR review skill to review what I had done. It was a couple minor changes after that, and I was able to, I'm happy to say, make my first open source commit. So I was very, very excited about that. Really, it was all about that context that I was providing into that skill into Claude Code that was able to help me get this. And that, as we've seen with the Pinterest presentation, is context is king when you're dealing with AI. And that is exactly why AI is so hard for data, because without that context, you need a clean data set, you need crystal clear metric definitions, or you're not going to get consistent answers across different teams. And that is why that context layer is even more important today than it ever was before. We can't have data or data responses hallucinate. It could be at risk of making a poor business decision. We can't have it just provide us with raw data tables when how we report might be on pivoted columns or writing specific formulas. We need to provide that context so everyone is having consistent and trusted results across the business. And this is where Omni's semantic layer comes into play. It allows us to have standardized business metric definitions, but also standardized context definitions as well. So the AI model is speaking the same language as our data team. And how we do it here at Omni is that the data team can input that directly into our semantic layer, where we can set that at the topic level or the column level, as I said. And then we can democratize that context building out to the rest of the team, where I can start interacting with the data through AI and checking the work that it's doing. And if I think I need to change some of that context within my workbook environment in a GUI interface rather than the code, I can then input new context that I might want to see. Or me as the marketing team, I might know exactly what ROAS means to my business. So I can put that in there. And then we have a real Git workflow where me as a business user can open up a pull request with the data team, and they can then approve those changes from there. So let's see how this works, and I'll get into a quick demo real quick. So first, I want to dive into our DataHub integration. So we built out this DataHub integration, and we can see here we already have an Omni dashboard. I can jump into that. I can see all the contents in here, my documentation, my tags, and then I can jump into the lineage UI and see how one dashboard can see all of those different charts on there. This one here is actually even an AI summary visualization, and we can see the topics that comprise of it, get all the way down to the columns that are in there as well. And then even if there was a DBT model in between this, we'd see that here. But right now we're just seeing the underlying data warehouse table. We can always, from a visibility standpoint, jump back down into Omni, actually see this dashboard that is comprising that asset. Now, in Omni, all of these metrics here are going to be backed by that semantic layer. And this is really, really important because, if we're thinking about something like an AI-powered summary tile, like this is where you're going to see that context coming into play right here. But it's going to even more come into play if I was actually chatting with my data. So if I wanted to say like, show me my team's performance, that's a rather vague question. But within the context layer, I have baked in what performance means to us. And I've also can set user attributes on individual users and individual groups so that when I say my team, it knows what values it needs to filter on. Me, I'm a sales manager in the North American region. So it's going to give me my team's results here. So even though like everyone is talking about my team, it needs that context over what my team means, not only for the business, but for the individuals as well. And you can always validate those results. You can always jump into the workbook model, and I can start modifying this report from there. And it even allows you to do things like creating dashboards and content. When I want to create content, I need it to know the context about my business. So when I did this before, because I didn't want to wait on it, and I pop this open, it is putting those key metrics up top that we care about. Like this is a sales pipeline dashboard, and it's giving me those metrics I care about. Now, when I look at the workbook and see how we're providing context into this, me as a user, I can come in here and actually edit this field and provide AI context right here, open up a pull request from my data team, or my data team can come in and actually edit the topic as a whole and provide it in a YAML-based approach if they wanted to. All of this can be done also within an AI coding agent via our CLI or our skills, all that good stuff. Really, it's all about creating many different modalities as we're context building, as I get signed out. If you want to learn more about Omni, or you want to learn more about how I built this, I highly, highly recommend going and looking at the DataHub skills. They were so valuable to me. If you want to learn about our Omni integration, check out the docs for Omni on the DataHub documentation. If you want to reach out, just learn more about Omni, you can always reach out to me, peter@omni.co. Thanks, everyone.
Awesome. That was such a great presentation from both the Pinterest team and then Peter at Omni about how context is really important for all sorts of talk to data use cases. Hi, everyone. I'm Shirshanka, and I am going to share one quick thing before we let Jars take the stage and talk about his experience with the community and what he's doing with DataHub. So quick thing, I think we all saw this today, so I don't need to repeat it again and again. Every talk to data agent ends up having pretty much the same blind spot. The models have improved, so the SQL is mostly right, but the answer is usually wrong because of the context gap. And that context gap really is more about understanding the business, understanding the technical context, and understanding how definitions really flow from one system to another. And turns out in a lot of organizations, especially the DataHub community, you've already done a lot of the work. You've already built the context. DataHub already knows your technical facts, lineage computed across all of our connectors, quality signals that are being monitored in production, all of the usage patterns from real analyst behavior. Pinterest talked about how the queries that they gleaned from all of their warehouse drove such important signal into understanding what is important and what is authoritative. And then, of course, there's classification, ownership, tags, all of the hard work that you've already done. That's already there. And then on top of that, you have your business vocabulary, your glossary terms, your domains, data products. And now DataHub supports documentation from any knowledge source, so you can kind of semantically embed a lot of that. And what we also see is a lot of companies and a lot of community members are, playing around with AI and often building agents from scratch. And that's really great because it allows you to get a sense of how to build these things, what works, what doesn't work. But oftentimes, those build efforts get stuck in building a separate semantic layer from scratch, populating your own vector store with DDL and docs. And very soon that agent kind of takes a life of its own. It has business definitions that it is storing within itself, and it essentially becomes a context management problem that you as a team are taking on. And we've seen this pattern both in open source community members as well as in our customer base. And we've been thinking, what if we actually gave people a blueprint? What if we actually gave you a reference implementation for how to build an agent with DataHub? And so today I'm excited to announce that we are open sourcing a DataHub Analytics Agent. It's Apache 2.0. You can try it out today. And it's basically just a web app that you deploy alongside your DataHub instance. That's the simplest form that we thought would be useful for the community. But of course, behind it is a very capable agent built on top of the LangGraph framework. You can ask it questions in plain English and get back SQL-backed answers with charts. I mean, it's meant to be a reference application. You can bring your own LLM, and it connects to your warehouse, Snowflake, and all the usual suspects. And I think it's a very important moment for us because it allows us to help you build conviction around your context layer, build a lot of those habits that help you understand where your context needs to improve, and really showcase the power of a grounded context-based LLM agent to your team, to your organization, as well as to your higher level execs who are wondering when they're going to get insights from data using AI. And the thing that, of course, makes it different is it reads from the context your organization has already built. You already have DataHub. It's already getting populated. And of course, it writes back as conversations happen. So it improves context as you interact with it. And as a result, the context platform gets richer and your answers get better. The architecture is very simple. All you need is 3 connections. DataHub for context, we already support MCP, we already support skills, and this agent connects to DataHub using all of those underlying capabilities. And of course, you need a connection to your warehouse for data via the standard drivers. And you need an LLM, which needs to be configured for your thinking. How does it work? It basically works with both DataHub Core and Cloud. So that was very important for us, making sure that we were able to provide you with an agent that you can get started with today. And the idea is that it connects to DataHub Core or Cloud over the same rails as DataHub supports both in Core and Cloud, which is MCP, APIs, skills. And some details will differ, right? So your users interact with the analytics agent or other agents talk to it. The agent itself is connected up to your warehouse, and it's talking to your warehouse using standard data queries. It's got access to an LLM that it uses for thinking. And then for the context layer, or the context platform, it's using DataHub Core or Cloud. And of course, depending on the capabilities of the system, you get back different kinds of results. For example, in Core, you're getting more vanilla context reads, whereas in Cloud, there are automations that are running, enrichments that are running, semantic agents that are running, and kind of not only giving you back what DataHub has ingested, but also refinements and intelligence that has been applied to infer more things beyond what was ingested into DataHub. And then as the analytics agent does work, it actually updates context back. So it's a pretty simple architecture. It allows you to keep your data plane and your metadata plane separate. And that, I think, opens up a lot of use cases for the agent to also be easier to deploy in your environment. With that, let's take a look at what the setup process looks like. Pretty simple. You start off, asks you to name it, then you pick a model. We've tested it out with a few different ones. As expected, Opus 4.7 does exceptionally well, but Sonnet is also pretty capable. And then you connect it up to DataHub. And after that, you start interacting with it and getting kind of the same kind of proof points that we've seen today with Pinterest and Omni, right? You get provable, grounded answers in context. The agent actually is continuously running and evaluating the context quality as well as you're engaging. So you also get trust signals as you're interacting with it and understanding what it's providing. This is an example of a good conversation where there was a glossary term. And so when we asked, which sellers have the worst delivery SLA, it was able to pull up that from the business glossary and use that definition precisely to get a very precise answer. And you'll see the context quality essentially goes from poor to really good as this conversation progresses. So this is an example of a good situation, but that's not life. There are many cases where there are gaps. And so in this case, we've got a conversation where we asked about what product categories are considered sensitive. And guess what? There was no definition for the concept of sensitive. And the agent tries its best. It searches across the catalog, across documentation, across many other places, and then says, you know what, I didn't find any definition for classification. Would you like to improve context right now? Would you like to tell me what you mean by sensitive? And we have a skill baked into the agent where you can essentially do improve context, and it kind of reflects on the conversation and helps suggest what gaps could improve the context further. And those improvements obviously are written back into DataHub. It could be an update to a glossary term. It could be a whole new document itself, or a correction applied on top of an existing document. Of course, this is done in the context of a single interaction. DataHub Cloud has a lot of automations built in that are kind of enabling some of this context curation and context refinement to happen in the background. And then this agent kind of benefits from all of that automatically. So just to wrap it up, DataHub is already present in your organization. You can use it as your context platform. And the analytics agent, which we just open sourced today, puts it to work. So go scan that QR code, check out the repo. This is day 0 for us, and we're excited to see where the community takes it. With that, I'd like to hand it over to Jars.
Hey, am I audible, guys? Can you guys hear me?
Yes, you're audible, Jars.
Perfect. Hi, everyone. How's it going? I see a lot of engagement in Slack and the chat as well. Seems like we're having an amazing town hall. So yeah, that's me, Jars. I am here to present my journey with DataHub, what took me towards DataHub and what I've done, what I've implemented at my workplace, and what I've been experimenting it with. So the title, as you can see, catalog to context, how I have transformed data from just a catalog to a complete context layer. So before I begin, I would like to ask you guys a simple question, especially to all the data nerds over here. Is your data catalog just sitting there as a static library? Well, if it is just sitting there and not being actively used in some sort of operational pipeline, you guys are missing on a lot of exciting stuff. Well, this is me, Jishan Ahmed A.R. Sheikh. I'm actually known as Jars. I handle engineering at PassionBytes. It's a data engine company. I contribute to open source, and I am a very community-driven person, and that has brought me in this tunnel. So let me begin with my journey. Nothing fancy, nothing too complex. We just had a client requirement on this 2 specific keywords, which you guys see on your screen, data classification and metadata. So client wanted an implementation with respect to the data classification, tagging, all in all, the business definitions and something on the catalog side. That's it. So phase 1 of my journey was something totally encapsulated around data catalog. So I implemented this catalog using data, and that's it. Later on, this cute tiny little robots came in, which we all term as AI agents, co-pilots, chatbots. Well, we had this agents coming in, working with our data, but these agents were directly hitting walls. I mean, these agents were completely sometimes giving vague answers, even though these were properly fine-tuned and properly, had all the base which was required to prepare those agents. The problem was something that had led us into a complete meltdown, like why this is happening, why are these agents blind? So we sat down and it clicked my mind that, hey guys, let us stop for a moment. Let us think on this thing. So I pitched it to my team that, guys, we do not need to reinvent the wheel from scratch. The answer to this problem is already something that we have implemented, and that was nothing but the data catalog we implemented in the phase 1. So that is the answer to how do you give sight to a blind AI? How do you handle those AI agents, those AI co-pilots? How do you give vision to those AI agents so that when a user is putting in a query, let's say the query is show me sales from the last quarter, the agent is not just blindly going in, getting hundreds of thousands of tables and just playing a guessing game. Okay, this table is to be chosen for this use case, that table is to be chosen. It should be like that. The agent should exactly understand what tables are for what use cases, because without context, which is the theme of the town hall, without context, these agents, these AI co-pilots are just going to treat your data as random entities. So I had come up with this golden flow that user will ask a question that AI agent is not going to touch your enterprise data directly. It will consult the catalog, which is DataHub context layer. The DataHub context layer is going to provide the agent with some meaningful insights. Okay, the query is related to sales domain. These are the certain tables. These are the gold standard tables. These are the tables with higher priorities. You can leverage this. If a query comes in the engineering department, I mean, when vice versa, if a query comes in the finance department, then that DataHub is going to provide the agent with the finance domain or the tables which are related with the tags which are presented in the financial aspects. Now, eventually, as I said, phase 1 was basically an implementation of DataHub as a catalog. Eventually, during phase 2, when we worked around the agentic architectures, DataHub became a complete golden stream of context. And for all the engineering nerds over here, this is how the architecture looks like. Thank you, Laksha, for this, by the way. So as you can see, we have data sources on the left side, all the external AI engineering world on the right side. DataHub sits as a context layer between the user. Now, this was phase 2 of my journey. First phase was catalog, second was the agentic engineering. Now, the third phase is much more of an idea that hits you when you're sleeping. At 3 a.m., something hits me. Okay, if you have DataHub, it is obviously the best thing to have the entire context of your organization's data segment. When I was working on this agentic architecture, what hit me is that, of course, DataHub is giving me context about my organization's data, all the data sources, the meanings and everything. What if the current AI engineering tools, which are there on the right-hand side, if you can see, what if I can bring context from this AI engineering aspects, from the AI engineering world, that AI context into DataHub as well? Wouldn't that be fascinating? So I sat down, I had this idea, I had the intention of bringing in the AI engineering context into DataHub. I had the clarity that I won't just run into tens of hundreds of things at once. I would start off with the vector DBs. And in vector DBs, I would start off with the Pinecone connector. like building a Pinecone connector, which will connect to my Pinecone vector DB and ingest some metadata into DataHub. So this was my plan, but I lacked one important thing. Well, the DataHub code base is a huge code base, man. I cannot just start off heavy engineering work without any idea. So I had this blocker, the experience, the hands-on expertise on DataHub from an engineering perspective. Then the DataHub community stepped in. And what was it? Any guesses? Well, it was nothing short than the DataHub skills. Well, if you guys don't know what DataHub skills is an agentic framework which is absolutely fine-tuned on the DataHub code base, which is absolutely loaded with the DataHub standards and everything. So you come up with ideas, you come up with clarities. You do not need hands-on expertise with the DataHub code base. You can just plug this DataHub skills as an NPM package into your Cursor, Kiro, Antigravity, or whatever you work with. And you can just prompt your way with the engineering side. And that's how I was able to build my Pinecone connector with the help of DataHub skills. And obviously, I would like to give a big shout out to Thomas, who was one of the best personalities I've met in this DataHub ecosystem. He was with me throughout those CI/CD checks, which I was CI/CD failures, which I was facing when I was building this connector. So thank you, Thomas, a lot. So what are the key takeaways throughout this journey? The phase 1, catalog. Phase 2, the agentic walk. The phase 3, the vector DB connector. The thing is, for sure, you can bring in a lot of AI computation. You can bring in the strongest model. You can bring in swarm of AI agents into your organization. But without context, they are just going to play a guessing game. With context, they're going to actually understand what they are doing and what are the expected results. Second thing, it does not matter what experience do you have. If you want to build with DataHub, come with your curiosity, come with ideas, come with proper intention, come with clarity. The experience will sort it out. DataHub skills is there. The entire community is there. The third thing is what I've learned. Keep exploring and keep building. Why is that? If I stopped at catalog, I wouldn't have been able to solve the problem we face in the agentic architecture. If I stopped at the agentic architecture, I wouldn't have been able to build a vector DB connector. And then you guys might be wondering, Jishan, that's it. Catalog, agentic walk, vector DB connector. Well, actually, no. I saw some loopholes in the DataHub skills framework. What I did is that I used DataHub skills and I started contributing back to DataHub skills. Isn't it fascinating? The very own framework that enabled me to contribute to the DataHub project, I'm contributing to that. Well, that's me. That's my journey with the DataHub ecosystem. I hope you guys enjoyed it. Looking forward to interact with you guys in the community channels. Jars out.
Thanks, Josh. All right, everyone. What a session. We went a bit ahead, but I think it was great. Huge thank you to all of our speakers today. Pinterest team, an incredible deep dive into what trusted context looked like in production at scale. Thanks to Peter. Great to see the ecosystem plugging into DataHub as well. Also, it was really exciting to see the analytics agent too. It's open source, and link is in the chat. I think quick start is just one command. Try it on your DataHub this week and share your feedback in the community. And yeah, Jars, from catalog to context layer, from community member to contributor, I think that's what open source is all about. Yeah, so it's a wrap up. Keep the conversation going on in down on Slack. All the resources and links will be shared there. And community servers open till April 30th. And do join in the Bay Areas groups fireside chat at Stanford next Tuesday. So we'll see you all next month for the May Town Hall. Thanks everyone. Have a great day.